Okay, lesson 1.6, radicals and fractional exponents. Okay, so fractional, or rational, really, exponents. Well, let's go back a bit. So in grade 9, we did a ton of this, right, with our exponents. You guys should be used to seeing this. If you got the same base, so let's say 4, and it was like 4 to the 5, like our example here, times 4 to the 4, do you guys remember the rule for if you've got the same base, what you do with the exponents if you're multiplying? Add them. Yeah, you add them, right? So that would just simply be 4 to the power of 9, right? Okay, we're going to be doing the same stuff now, but now these exponents that we're having in there, they're going to be fractions, right? So you might have fractions in there. You guys all love fractions, right? Everyone loves fractions? And actually the first part of this isn't even that bad at all. So, just want you guys to see the connection here. That if I had 4 to the power of a half, right? 4 to the power of a half. Actually, I'm going to pause for now. 4 to the power of a half is equal to 2. Can you guys do the same thing? Can you go the square root of 4? And what do you get? That's because they are the same thing. Square root of 4 is also 2. So we have a new way of writing these things. Like, so let's say if we had, well, let's just do these examples. If I had 16 to the power of a half, well, we could just write that as the square root of 16. They're the same thing. Right? So we're going to be making those connections between radicals that we were doing and exponents. So fractional exponents really are just like another way to write radicals. Yeah? Okay. So going through this, just some examples there. Here's our general rule. So if we have x to the power of 1 over n, x to the power of 1 over n, that's the same thing as the nth root of x. Okay, so I know that sounds confusing, but it's not that bad. All that means, if I put numbers in there for a second, that would be like this. If I have x to the power of 1 over 3, then that would be the same thing as, well, what would that n, like if there was a 3 in the bottom there, what will that n be now? 3, so that'd be a cube root. If it would have been 1 over 4, it would have been the 4th root. It would have been 1 over 5, it would have been the 5th root. Yeah? Okay. And let's do another example here too. Actually, no, I think that they'll be coming. So, unfortunately. Okay. So let's, I'm just going to pick one of these for the sake of time. Let's pick this one. So if we had 3 to the power, or sorry, 3 times the 4th root of 23. And it said to write that in exponential form. Okay, so that just means with an exponent. So yeah, this 3 up front, that just means 3 times that. So that's going to still stay there. That'll be 3 times. And then how do I write this 23 part? That'll be, seems like Blaine's on it. Right, yeah. Yeah, 3 times 23 to the power of 1 over 4. Yeah, you guys are getting it? Yeah, it was. Yeah. Okay. Now, we're going to have a similar thing happening here when we have, here, I'll just give you a separate example here. Well, I'll do this one. So we'll do this one first. So if we had the cube root, or sorry, square root of 3 to the power of 3. So the square root of 3 to the power of 3. And I want to write this as just an exponent. So it's still going to be 3 to the power of, like the base is the same still. So it's going to be 3 to the power of. And then in this case, the exponent goes on the top of our fraction. So it's going to be 3 over, and then what kind of root do I have here? This is a square root. So there really is like a 2 there, right? So this would be 3 to the power of 3 over 2. So the bottom number is the index, and the power is still the power. Okay, this would be the same thing if it was written this way. It'd still be the same. If I would have had the square root, I'll put a little 2 there, of 3, and then the whole thing was to the power of 3, that would also still just be the same thing. It'd be 3 to the power of 3 over 2. It doesn't matter. Do you see how in the first one the exponent was like under the square root, and in the second one the power was like outside, like in brackets? It doesn't matter. So it's just power is the top number. Your index is the bottom number. Okay, so yeah, we'll do the next one here. So let's do that guy. So that would be here. I'll just write it one more time. 2 times the cube root of 6, and then to the power of 2. So all this is this 2 out front is still just going to stay out front. So that's going to be 2 times 6 to the power of 2 over 3. Yeah, same thing. This is why some of you guys were having trouble finding like the 4th root button or the 5th root button and all that kind of stuff. For some of you guys, I said, well, why don't you just go, you know, if it was the 4th root, let's say we wanted to find the 4th root of 3 or something. Well, that'd be the same thing as you could type it in your calculator as 3 to the power of 1 over 4. That's typically how I do it. Like if I'm finding the 4th root or the 5th root, I just change it to an exponent like that.
What if the number is higher?
That wouldn't matter. So if we had like the 56th root of 1,000, then that would just be 1,000 to the power of 1 over 56. Be the same thing. Okay. Moving on. Yeah. Can you guys do these ones? I'm going to pause it. So here's your answers, guys. If you're watching the video, then just maybe pause it so you can check your work there. Just know this too. So what we did here with the 0.75, right? We just changed that to 3/4 and then did the same little trick there. Either one of these is okay way to write it afterward. You could write it as 4th root of 5 and then all to the power of 3, or the 4th root of 5 to the power of 3 underneath the root would be the same answer either way. Okay, moving on.
This looks hard.
Nah, it's not too bad. Okay, so there's some good examples here. I think I'll go through these examples. So, okay, so it says evaluate each of the following. So we got to evaluate 100 to the power of a half. Sometimes these are easier to change it into like a radical, like square root here, because 100 to the power of a half, well, that would be the same thing as just saying the square root of 100. And you guys probably know that one, right? The square root of 100 is 10. So that's the same thing as 10. Okay. Now, 1,000 to the power of 1 over 3. Well, that would be the same thing as the cube root of 1,000. And the cube root of 1,000. Anybody know that one? Yeah, 10. Because think that's that 10 times 10 times 10. Yeah, 10 times 10 is 100. Times 10 again, it's 1,000. So that'd be also 10. All right, there should be lines in that. Is there lines in yours? Okay, yeah, write those lines in. Okay, so 4 over 9 to the power of a half. Now this looks confusing because there's like 2 fractions happening there, and one's in the exponent. You guys have done ones like this though too, right? To the power of a half, that would just be the same thing as the square root of 4 over 9. And then 4 is a perfect square and 9 is a perfect square. So I just take the square root of both, right? Take the square root of the top, take the square root of the bottom. So that's just 2 over 3.
Square root of that?
No, that is the answer. That we took the square root to get that. Yeah. Yeah. Okay. So the next one, there should be a line there too. Okay. So a little bit more complicated now because we got 3 over 2. Let's write it as a radical so we can get our bearings here. Okay, so this is going to be 9 over 16. And it's going to be a square root because of the bottom, right? So you can put a 2 there if you want, or just leave it as the root symbol. And then we're going to have to cube that, right? The top number is what we do after. You can do these in any order. We could cube it first. Like I could have cubed the 9, cubed the 16, and then took the square root of those, you get the same answer. This one's probably going to be easier to take the square root first, though, right? Because I'm looking at 9 over 16. Those are both perfect squares. Let's do the square root part of it first. Okay, so what would that be? That would be the square root of 9 over 16 would be 3 over 4. Okay, so we did the square root part. We've still got that to the power of 3 part left. So 3 to the power of 3 and 4 to the power of 3, right? They both get raised to the power of 3. So 3 to the power of 3 is 27, yeah. 4 to the power of 3, 64, yeah, good.
Wait, can't we
And we did that all in our head.
now?
Okay, so actually let's... Well, you know what? You guys will run into those. You can look at that for an example, right? Like it's all kind of laid out there for you. So I'll skip through the nasty question of the day too, just to get to the next questions.